Okay, so we're going to talk about the last question from the problem-solving section of the homework, and it's all to do with rate of growth of yeast in culture. So the first question gave us some information, and it said that the rate of growth was proportional to n, and the rate of growth is with respect to the number in there and time. So I can express rate of growth as dn over dt, and that is proportional to the number of yeast in there. So I can then add a constant, and I've now made it proportional to. At this point, I can just rearrange this, take the dt over here and the n over here, and I get 1 over n dn is equal to k dt. I can then integrate both sides, and I get ln of n is equal to kt plus c. Then take e of both sides, so n is equal to e, so the kt plus c. And then we can call e to the c just a different constant. So we'll call it a, e to the kt, and we have now got what we needed to do. The next part of the question gave us some information about it and asked us to work out how long would the number of yeast exceed 10,000. So I used the information from two. It said initially there was 200 in there. So that leads us to know that A, so the first value, is 200. We're told that after 2 hours the number was 3,000. So we can use that information to find out what our constant K here is. So we know that 200 times e to the 2k is equal to 3,000. This will lead me on to find out what k is. So if I divide the 3,000 by 200, I get 15, and then I can find k by doing ln of 15 divided by 2, which is 1.354. I'd say at this point it's okay to leave that to full significant figures. Okay. So now I do know that my equation looks something like this. I know that n is equal to a, which is 200 times e to the 1.354 t. And at that point, I can solve it then with finding out the value of t for which this exceeds 10,000. So I need it to exceed 10,000. So I'm going to divide by, do 10,000 divided by 200, which is 50, and then do ln of 50 to get rid of the e, and divide by 1.354. And I get that t must be bigger than 2.89, we'll call it. But remember that this is in hours, so I've been asking the question to put it to nearest minute. So it's going to be 2 hours, and if I do 0.89 times 60, I get 53 minutes. So as long as t is greater than 2 hours and 53 minutes, the amount of yeast will exceed 10,000 pieces. Okay. The last part wasn't too dissimilar to this one, now that we know some information about what's going on. The tricky thing was the fact that it was in 5 per second. So far everything we've dealt with has been in terms of hours, so it's going to be useful for us to convert that into a rate per hour, which is 18,000. Then we're talking about the number of cells increasing at a rate. So actually we're going to go back to the first bit of the equation that we set up, that was to do with rate of change. So the rate is going at 18,000, and the rate can be expressed as the rate of change is equal to k multiplied by n. But we know these things. We know that k is 1.354, and we know that n is 200 times e to the power 1.354t. So we can divide by this on this side here. So 18,000 divided by 1.354 times 200, and I get 66.47 is equal to E to the 1.354t. So if I then take ln of both sides and divide by 1.354, I get ln of 66.7. I get t is equal to 3.10. So equals 3 hours and 6 minutes.